to another application program located on another network. The OSI reference model divides the problem of moving information between computers over a network medium into 7 smaller and more manageable problems. This separation into smaller, more manageable functions is known as layering. So the interaction between layers in the OSI model. Communication between P layers is virtual. In reality, communications pass up and down the protocol stacks on the machines. As data gets passed from layer to layer, it's divided into data units appropriate for the layer. Protocol data units are passed as a self-contained data structure from layer to layer. Encapsulation process adds headers to allow successful delivery of each layer's payload. And decapsulation strips header information on the way up. No layer can pass information directly to its peer counterpart except for the physical layer. So this is 7 layers of OSI model. First, physical layer and data link, network, transport, session, presentation, and application. So in the physical layer, there is binary transmission. In the data link, access to media, network address and best path, transport end-to-end connection, session layer, inter-host communication. In the presentation layer, data representation, and application layer, network process to application. So, duties of physical layer, low level of their OSI model. Provides physical interface for transmission of information. Provides physical interface for transmission of information. Defines rules by which bits are passed from one system to another on a physical communication medium. Covers all mechanical, electrical, functional, and procedural aspects for physical communication, such characteristics as voltage levels, timing of voltage changes, physical data rates and maximum transmission distances, physical connectors, and other similar attributes are defined by physical layer specification. And line configuration we have, and the physical topology and the transmission mode. In the line configuration, physical layer is concerned with the connection of devices to the media, point-to-point or multi-point. Physical topology. Devices can connect it by using star topology, mesh topology, bus, ring, or hybrid topology. In the transmission mode, it defines the direction of transmission between two devices, simplex, half duplex, or full duplex. Next layer is data link layer. Data link layer attempts to provide a reliable communication over the physical layer interface. breaks the outgoing data into frames and reassemble the received frames, create and detect frame boundaries, handle errors by implementing an acknowledgement and a retransmission scheme, implement flow control, supports point-to-point as well as broadcast communication, supports simplex, half duplex, and full duplex communication. The next layer is network layer. Implements routing of frames, pockets through the network. Defines the most optimum path the pocket should take from the source to the destination. Defines logical addressing so that any endpoint can be identified. Handles congestion in the network. Facilitates interconnection between heterogeneous networks, internetworking, and the network layer also defines how to fragment a pocket into smaller pockets to accommodate different media. So this is example. So each computer is connected to only one link and therefore has only one pair of address, logical address and physical address. Each router, however, is connected to three networks, LAN 1, LAN 2, LAN 3. Therefore, each router has three pairs of addresses, one for each connection. Transport layer. Purpose of this transport layer is to provide a reliable mechanism for the exchange of data between two processes in different computers. Ensures that the data units are delivered error-free. Ensures the data units are delivered in sequence. Ensures that there is no loss or duplication of data units. Provides connectionless or connection-oriented service. Provides for the connection management. Multiplex multiple connection over a single channel. And also we have example of transport layer. So port addresses is 16-bit address represented by one decimal number. Two personal computer, two PC, yeah, A and B, communicating via the internet. The sending PC is running three processes at this time with port addresses A, B, and C. Look at the image, please. The receiving PC is running two processes. Receiver. Yeah? Видите? Do you see? Two processes at this time with port addresses J and K. Process A in the sending PC needs to communicate with process G in the receiving personal computer. So next layer is session layer. Session layer provides mechanism for controlling the dialogue between the two end system. It defines how to start, control, and end conversations called sessions between applications. Еще раз повторяю. Session layer provides mechanism for controlling the dialogue between the two end systems. It defines how to start, control, and end conversation or call sessions between applications. This layer requests for a logical connection to be established on an end user's request. Any necessary log on or password validation is also handled by this layer. And session layer is also responsible for terminating the connection. This layer provides services like dialog discipline, which can be full duplex or half duplex. Session layer can also provide checkpointing mechanism such that is a failure of some sort occurs between checkpoints, all data can be retransmitted from the last checkpoint. And we have presentation layer. Presentation layer defines the format in which the data is to be exchanged between the two communicating entities. Also handles data compression and data encryption, cryptography. And the last layer is application layer. Application layer interacts with application programs and is the highest level of OSI model. Application layer contains management functions to support distributed applications. Examples of application layer are applications such as file transfer, electronic mail, and remote login, and etc. So, in the conclusion, OSI in action. A message begins at the top application layer and moves down the OSI layers to the bottom physical layer. As the message descends, each successive OSI model layer adds a header to it. A header is layer-specific information that basically explains what functions the layer carried out. Conversely, at the receiving end, headers are stripped from the message as it travels up their corresponding